Let's talk about a removable discontinuity and how we deal with it. In this case, we got a function that's going to have a removable discontinuity because there's a single point where it's not defined, but by defining it at that point, we can make the function continuous. So clearly, this function is discontinuous at 4 because 4 creates a 0 in the denominator. So currently, x cannot equal 4. So what we need to do is figure out what we need to define it to be in order to make that function continuous. So what we're going to do is we're going to look at the limit as x approaches 4 of our function. X squared minus 2x minus 8 over x minus 4. Well, we're going to solve this limit using a little bit of algebra. The top will factor into x minus 4 times x plus 2 over x minus 4. Those x minus 4's will cancel as far as the limit's concerned, and now we can calculate this limit via direct substitution. In fact, it equals 6, which means we need f of 4 to equal 6 to basically plug the hole that's going to be missing in our graph. So what we're going to do is we're going to now define f of x to be a piecewise defined function. So x squared minus 2x minus 8 over x minus 4 for x not equal to 4. And we're just going to let f of x equal 6 for x equal to 4. Because what we had graphically is, if you were to look at this in a graph, at 4, this thing would look like a lot like a linear function, a lot like x plus 2, except there would have been a hole there at 4. What we did, let's make that a little bigger, is we basically plugged that hole by saying, okay, well, we're just going to make f of 4 be 6.